Perfect.
Hello, everyone. Good morning. I have the great pleasure. It's not off on the meeting, it's over here. So, I have the great pleasure to host today Roberto Di Cosmo. He's an evangelist of free software. And by coincidence, we had the chance to work with him in a a big project, Calypso. And on this project, it was nice because was the creation of our free software competence center. And somehow you were involved on it because there are several free software competence centers in the world. And we are doing free software here. And we have several students here that really enjoy and contribute to free software. So without further delay, please go ahead and present to us the software heritage.
Okay, so first of all, my apology for being late. It took a lot of time to get a taxi for some strange reason, and this is a very popular place, everybody's coming. So, but it's a real pleasure to be with you today, seeing again Fabian and other people we were collaborating with many years ago. And today I'm going to talk to you about a project which is called Software Heritage, but under a specific focus, which is open science. So let me start with a short introduction about myself. My name is Roberto Di Cosmo. I'm a computer scientist. I have been teaching, doing education, educated the next generation of researchers, engineers for over 35 years. I spent a quarter of a century advocating for open source, funding open source, funding, not with my money, I'm not rich, but I mean trying to help using public money to fund free software, also defending free software against some bad legislation. And this has disappeared, no, it's fine. And then with the time, you know, my beard is getting gray, you get older, so I decided to take responsibility in directing or creating organization for the common good. And in particular today, I'm going to talk to you using two different hats. You see, I do not have a lot of hair, so I wear many hats, typically. One is I am a member of the National Committee for Open Science in France, where I chair the Software College. You will see this is kind of new. Usually we understand, modify, build upon. And when this was written in 1985, we didn't have access to a lot of software, but today we have access to an incredible amount of source code. Starting from this is a small excerpt, a few lines from the 60,000 lines of assembly code that was embarked on the lunar landing module when we managed in summer 1969 to put a man on the moon. And actually, let me mention something that people tend to forget. If we managed to put a man on the moon, it was because a woman, Margaret Hamilton, directed the team of programmers that created this software. And Margaret Hamilton, by the way, she's still alive. She's still directing a company doing high security and safety software. She's an incredible lady. If you want to know more, I have more anecdotes, but this for the coffee break. But you see, in these lines, here on the left, you have assembly code, which is very fine for us since we are computer science. But look on the right side. These are comments. These are written in English. These are messages, not for the machine, because they will be ripped off by assembler. They are messages to the person who will be able to modify or understand this thing. But you say, okay, but this had comments because the assembly code is not very readable. Okay, so fast forward 50 years, this is, I'm sorry, very unreadable, but I can show you a little bit what it is. This is a fragment of COVID sim. It was a simulator, the tool that was used to simulate the expansion of COVID during the COVID crisis, written by a biologist in England. And you see, this was written in C, which higher level language, and still comments all over the place, because these are messages sent to the humans. And actually, like Donald Knuth, who is one of the founding fathers of computer science, used to say, programming is the art of telling another human being what we want the computer to do. Okay. And so this means, as Len Schuster, who was the board director of the Computer History Museum, that if you really want to understand what a program does, you need the source code, and the source code opens up for us a view in the mind of the designer. Why I'm insisting on this with you, that you know this already, right? But because you need to remember the arguments to talk to other people that forget about the importance of source code or development in what we do. Now, you have, probably not you in Brazil because you have stronger feelings, but in many places in the world, people have a tendency to believe that everything computer science happens in Silicon Valley, right? This is not really true. I mean, through software heritage, that you will discover in a few minutes, we could do this kind of study. Actually, this was done by Stefano Zacchiroli, who is my co-founder with Software Heritage. These are 50 years of software development at a world scale. And if you look at the email addresses of the people, now you look also at which time in the day people are doing the commits, etc., you can separate by regions a little bit. And so you see that even if there was a moment where most of the software was done in the US and in Europe, today, over a third of software development, as far as we can see through the Software Heritage Archive, is completely non-US, non-Europe. And then I have some more surprises for you about USP, we will see later. Also, the amount of source code which is created every day is staggering and exponentially growing. This is analysis, again, performed on all the contents of the Software Heritage Archive that shows how since 2000, the number of new original pieces of software grows exponentially and doubles every 2 years. After COVID, we all read very easily linear logarithmic scale, right? I mean, so this is logarithmic, this is linear, so a straight line is an exponential. And the factor is actually an exponential, almost 2 years for doubling the contents and almost 3 years for doubling the number of commits. Now, let me take a few seconds to make a comment. You see, it was not the case before. You had more commits and less creation. And then at some moment, something happened and you start having more contents and less commits. Do you know why? I'm not sure, but my interpretation, if you look at the moment where this changes, is the moment we start having modern version control system. So for old guys like me, if you remember, I was using CVS or Subversion as version control system. Merging contribution was a disaster. So as soon as I made a modification, I committed something, so the mess was on the table of the neighbor and not on mine, okay? So that was, you have basically one commit, every content was a commit. Then you start having tools like Git that has super powerful merging strategies. I don't know if you ever had the chance to witness an octopus merge strategy in place. Who cares? I mean, I do the modification I want to. When I'm really happy with the commit, then I push a commit. And so you see this difference coming on. But anyway, so software comes from all over the world. Software is expanding at an incredible scale, and I'm not factoring in what may happen using generative AI in all this. So you can grow even faster. And so the question is, now that we know all this, what does this mean for science? For example, for when you do science. Well, if you look at open science, in open science, we have a tendency to say that software is crucial for developing knowledge. And so I have spent years telling everybody that when you talk about open science, it is not enough to talk about the publications, open access. Of course, open access is a big story because we keep spending hundreds of millions of euros every year in subscription, which is a disaster. But not only you need to have data, but you also need to have the software for doing this. Typically, if you have a paper that says, an article that says, I have taken this data, I've applied this transformation, the answer is 42. If you only have the article, that's basically an act of faith. If you have also the data, you can try to re-implement the transformation, run it, and then you get 56. And so why? if you also have the software that you have used for doing the transformation, the exact version of the software, the exact version of the data, you should be able to get 42. If you don't get 42, you should be upset. Okay, so that you need this kind of thing. But the interesting point is that in France, since 2018, France created a national committee for open science that was tasked by to create a policy for open science at the national level, the Ministry of Research, and actually create tools and create instruments to actually apply and monitor the evolution of these kind of policies. You know, if you cannot measure something, it is very difficult to check progress. And so here, one thing that was created in 2019 was the French Open Science Monitor. At the beginning, this was just tracking every year the percentage of open access publication by French researchers compared to the number of global publication of French researchers. And of course, as you want to see the percentage going up, okay, and it is actually going up. But then a few years later, we managed to convince the people at the ministry to add two other things. One is a data set, and the second is the publication, the software. How do you track software created in research? Not super easy, right? So the approach that was taken is to basically collect all the publication by with at least one French researcher, run machine learning models on top of that to spot mention of use, creation, or sharing of software. So if you read an article, in the article you see a phrase like saying, we have written in Python the tool foo, which is made available there. You have one mention of use, you have used Python, one mention of creation, to write the tool foo, and one mention of sharing, which is available there. Okay, and so this is run every year. So the third edition just came out a few months ago, and it provides us a view of the number of publications that actually mention use, creation, or sharing. And what we insisted on was to have a separation of the publication by discipline. This is not very readable, and I really apologize, but you will have the full slides, and everything in blue are links that you can click upon to get to the real thing. You know, this is my old professor habit. I do not like to say things we have without having supporting material. And here you will see that all discipline, from law, social sciences, geography, psychology, up to, of course, what you expect, engineering, physics, mathematics, computer science, they all use, produce, and share software massively. So software is important for everybody. And software is special because the same software tool can be a tool for me. I'm using this tool for doing machine learning or data analysis. But this tool is the result of the work of a research team next door, or can also be the object of study for another team in software engineering that looks at how software is developed and maintained over time. If you want to really take advantage of all these facets of software, you need access to the source code, of course. Now, again, this is not for you, and that I'm giving you some arguments for other people. During the past years in discussion at different level, policy level, in France, in Europe, etc., I have been confronted a lot of time by people telling me, well, okay, software you want to consider, but software is just a sequence of bits. A sequence of bits is data, so there is nothing special about software. So if you want to reference software, etc., you just put it in a data repository, get a URL, and that's okay. No. But so let me share, I'm sure you have many arguments, so let me share mine. Okay, so first, I mean, software is never finished. I mean, it evolves over time. If you have a data set with the, the hygrometry value of the Paraná River in the summer of 2021, that's it. You do not keep evolving it over time. You know, it is finished, you have provenance, etc. A software project can last decades, have variation all the time, but it is written by humans, so there are issues related to copyright. So software is under copyright law, not under, other low select data. And it can be very complex, either because a piece of software is very big, Linux kernel, tens of millions of lines, or because you just write 10 lines of code in a script in Python, but you do import matplotlib, and when you import matplotlib, you pull in tens and tens of packages and dependencies, etc., that are maintained by other people, etc., etc. So it's very complicated. Okay. And so this is precious, endangered, executable, and human-readable knowledge. Why I say endangered? Because not only some of the key people are passing away, and in our discipline in computing, we have a privilege that many other disciplines do not have. So mathematicians would love to be able to talk to Leibniz or to Archimedes today, but it's too late. In physics, you would like to talk to Newton, but it's too late. But in computer science, for a while, we are still able to go and talk to the people that actually started all this game. Every year we lose someone, we lose some friends, but we still can do that. So it's a privileged position, but it comes with responsibility. I mean, going, talking to these people, getting the software, getting the history out. This, but there are other issues too. I do not know how you do this. I mean, when you develop software, actually I know what you do. I will show you, but most of you, when you develop software, you develop it using some popular code hosting platforms. A lot of you are using GitHub. I know. Then some are using some other platforms, etc., etc., some GitLab instances, etc. And you think that this is okay, right? I mean, you put your software there, and so since you have put your software there, you just reference it, GitHub / my nice name / project. Fine. And then you go on holiday, and the software, when you come back, the software is there. But you know, code hosting platforms are not archived. We will come back to this. And actually, some of them were shut down. In 2015, actually it was the same month, March 2015. In March 2015, Google Code and Gitorius sent a message to all of their users telling them, we are going to shut down our platform. Well, actually, the Gitorius one was very funny, because in March 2015, I got a message from the CEO of Gitorius, as all the other users, that was done in the real US advertisement way. So it was saying, great news. Great news? Great news? You expect you gained something. I mean, the great news is that he is getting a Ferrari because he's selling the company to GitLab, who was a competitor. But then when you keep reading, it is less great news for me, because at the end it says, you know, now that we have been acquired by GitLab.com, it is not really reasonable to keep two infrastructure, right? So start your clock, starting from now, you have 3 weeks to take your stuff, because we will unplug the servers in exactly 3 weeks. So I do not know how you work, but anyway, you don't spend time reading emails from advertising every time, no? So you go out, you come back, you connect to see your project, and the platform has gone. 120,000 projects on Gitorius. No, wait, I need to put it. And 700,000 projects on Google Code, unplugged. That was something. Anyway, so the fact that software is important is finally getting noticed. So you start to have some policy observation. 2019, we convened 40 experts worldwide from different disciplines, libraries, archive, history of computing, computer science, other disciplines, policymakers. And this came out with a report that actually called to promote software development as a relevant part of academic work. Okay. Then you have the UNESCO recommendation for open science that came out in November 2021. And they point open source or free software as a key pillar for open science. Later on, we had a report at the level of European level on the importance to keeping track of open source and actually recommending using software heritage as a common layer. And you have many more things which are changing. Like, for example, in Germany today, if you apply for promotion or for funding, etc., there is a model curriculum vitae that you need to fill in, and instead of having just a publication, now there is a space for data set and for software which are evaluated and the base of quality. NASA did something similar more recently. In France, what did we do? So in 2021, you have this second French plan for open science. The QR code, I don't know how readable they are, but I mean, you have the French version and the English version. And this is a national 4-year plan for open science in France. It contains many axes, but between the axes there is one which is precisely termed opening up and promoting source code produced by research. And this involves a lot of things. I mean, recognizing software, in putting in place a policies that recommend to use open source as licenses for software produced on public money, I mean, unless there are reasons, I mean, privacy or whatever, etc. And one of the result was a creation of this college that I chair, and this college has 5 different areas. One identifying, highlighting research, software in research, looking at technical and social best practices for developing software, making, considering what are the best practices in technology transfer, having international connection and recognition in career. Now, let me focus on some of these things are available in English. Let me focus on one thing that we did and we are very proud of. One was to create a national open science award for research software. It was not an easy thing, so we had to go out and convince the Ministry of Research that this would work. Okay, when you are a politician, you do not want to create an award and then you have 0 application, or the people who win do something lousy. But the result is this. So in 2022, the first application, we got 129 applications from all over France, which was much more than what we expected, because this was a national award. So there is a lot of self-censorship when you apply for this kind of thing. And actually, I have to say, I convinced a few people to be part of the jury, also telling them, look, we expect maybe 30 applications. When they found out 129, I had to hide a little bit. And then they wanted to give an award to half of them, which was not possible. We ended up with 4 awards and 6 successes. Now, probably you recognize at least one of these software, right? I mean, scikit-learn, you know that? Well, scikit-learn is a worldwide success. It was developed by a colleague of mine many years ago for other things, for brain analysis, but it has been a huge success. They did not need the award, okay? Really. They even convinced the guy Varocco to be on the jury, so for the ontological reasons, scikit-learn could not be. But he spotted my idea and said, no, because we submit, and they won. But on the other side, I mean, this is for doing music, this is a proof assistant, this is for astronomy, and actually there was one which was very special, I mean, a software project developed by a lady, which was a research engineer in a linguistic department, alone, for 15 years. She developed and maintained under GPL license a software used by linguists for analyzing things, with 0 recognition. And you consider just a low-level technician. So seeing this lady getting the award from the Ministry of Research herself, in the School of Medicine in Paris, with a journalist taking pictures, etc., that was a moving moment, okay? And then if you go to the website of the lady, you will see there is a picture of her with and back in the university, now she is very well recognized. There was another project which is actually called WebOps. It is a tool used worldwide to track earthquake and volcano emissions, etc., developed by a small team in one of the French universities. they had been asking for one extra engineering position for years with zero answer from the university. After the award, guess what? They got the position, okay? And so this was 2022. Then we had 2023. I didn't put also 2024 and 2025 running, but the good news is that, one, this was super well appreciated. Two, it is considered the best quality award that we have in France in this open science initiative here. And three, it is institutionalized. So now it is a Ministry of Research that runs this every single year. Okay. It's not an easy thing, because you need to actually select the right jury, decide what is a French project, because this is a national award, so what are the limits? Do you accept a software which is able to run only on proprietary platforms or not? There are tons of choices to make. What are the criteria? But all this is now available. If you want, I can send you a pointer to a paper where we describe with other people from the Ministry of Research exactly everything we did. So all the blueprints are there, and it can be replicated in any places. So what is exactly at stake when you look at software in the academic world? For software that you have already written, basically you have four issues. One, where do I put it? I mean, Gitorios has gone away, so I'm not on a code hosting platform. How do I identify exactly the version which are interesting for me? How do I describe it in such a way that people can find it easily? And usually, how do I give credit for citation evaluation for the career advancement? This is for software you have already written. Then for software that you actually are writing or will be writing, so you need training, education material for knowing how to use properly the tools for developing software, how to create a community around it, I mean, if it makes sense. And all beyond this, you need to have at a national or federal level, I do not hear how it works, some direction or policy telling you what you should do about the licenses, how you should evaluate this as part of the career of researchers, engineers, etc. Okay. Now I would like to focus on this part, because this is where software heritage comes in. So, and here is where I'm trying to show you how we were doing preservation of the software associated to publication in the past. So, in the very old past, we put our software on something which are called FTP servers, File Transfer Protocol Server. I'm sure a lot of people do not know what this is. I mean, they are no longer supported in the browser or something. Then we moved to web pages. So I have software on mine on my web page. Okay? Actually, I had on a web page that disappeared, and I created mine, making a copy of it. Then people discovered that actually web pages disappear. And so they started saying, what can we do? Let's put it in a document archive and stick a DOI on top of this object. Okay? But this is not very developer friendly. Since software forges arrived, we have a tendency to point to the project in the forge. Because in particular with more recent forges, this is source code first. You connect and you see the source code. Okay? It's developer friendly. So it's pretty nice. Sometimes you have commercial free forges, sometimes you have institutional forges, I mean this. And then some of our own learned society, like for example, this is ACM, but IEEE does something similar, started proposing us to do a mix of the two. Okay, so for example, today, if you publish an article in some of the proceedings of the ACM, you can get nice badges, so the artifact is available, the artifact is reusable, whatever. And then you go to the digital library, and the digital library you find only the DOI, a DOI associated to the software, so DOI means nothing. You need the reference to understand what it is. And the poor author, so here I have hidden all personal details, the poor author tries desperately in the description to smuggle in the pointer to the forge, because he doesn't care about the UI. He wants you to find the software and point this to the forge. But then the only thing that you can do is download it with the zip file. So it doesn't really work. I mean, this is really poor user experience. You have no preservation guarantees here, and this is a kind of a mess that we can do better. So when I said forges are not forever, I already mentioned to you Google Code and GitHub, but that was not just the only thing. In 2020, Bitbucket removed support for Mercurial, and they destroyed over 300,000 projects. So this keeps on going, okay, this kind of thing. And so if you want an archive, you need an archive, not something else. And the good news is that now we have one. And this is where SoftwareEdge comes in. SoftwareEdge is an initiative which was unveiled in 2016. We started working on this in 2014. The mission is precisely to go out, collect every single line of code ever written, which is publicly available, preserve it, making sure it doesn't disappear, and make it easy to share and find it again. So preserving the past, I mean the Apollo 11 code, but also getting the software that you develop today in a special place where people can find it, reuse it, analyze it, study it. Okay, so we want to help building better software and better science for the future. In a nutshell, you can think of SoftwareEdge as a catalog. I mean, a place where you find the links to all the software which is available in the planet. Doesn't matter if it comes from GitHub, from an old source forge, from a Debian, or something like this. But also an archive, so you are sure the software goes there, stays there, doesn't disappear. And last but not least, it is a first layer of a much needed research infrastructure at low global scale to study the galaxy of software development. You know, it happens that one of my best friends is an astrophysicist, and he was the mission head of the James Webb Space Telescope. So we chat a lot. I mean, I'm very jealous because his budget has many, many more zeros than mine. But actually, these people, astrophysicists, they managed to spend 30 years, and $10 billion to build this incredible telescope which is sending images from outside space. Okay. We need to do the same. We need to build an instrument for us to observe software development at a global scale. We do not need $10 billion. It can be cheaper. Okay, but we should do it. Okay. And SoftwareEdge tries to build the first layer. How is it designed? SoftwareEdge is designed as a single infrastructure which is open. Everything we do is open source, so there is not a single line of proprietary software in all the stack of software heritage. Well, maybe there is in the microcode of the microprocessor, but this is something I cannot avoid. Which is open and shared. The idea is to have just infrastructure catering to several needs. I mean, it can be cultural heritage, rebuilding the history of computing, can be industry, research, administration. It is up today the largest archive of software ever built. These numbers are not necessarily up to date because they change every day, but we already passed 350 million projects. And you see, we are very transparent. You see really from the summer 2015 when we started to now, you see the evolution. And this is more than 23 billion unique source code files. When I say unique, if the same file content appears in 20 projects, we store it only once, and it is easy because we compute a hash function, and you see it is the same thing, like Git, if you know the model. And almost 5 billion commits, and these come from over 86 million contributors worldwide, over 70 years, I mean, the history of the system. Where do things come? GitHub, of course, the largest fish, the biggest fish in the pond, but also GitLab, and not just GitHub.com, but many other instances of GitLab, including yours here. Bitbucket, but also distribution like Debian, but also package managers like NPM or Maven or PyPy, etc. Actually, to be very transparent, we are today tracking over 5,000 different code hosting and distribution platform worldwide. Some are very small, but it doesn't mean that the software which is there is not important. Sometimes people just want to keep their software on their machines instead on other people's computer. And this is supported by UNESCO and the vision. To foot the bill, unfortunately, do not have the federal money that my friend has for the telescope. But I mean, we try to bring together different partners coming from private companies, from governments, from academia, from organizations, in a model which is basically sharing the cost between the different user and partners. And how do you build something like this? Well, it's complicated. So the first layer is we needed over time, over 10 years, to build connectors and adapters for each and every single technology which is out there to maintain software. So if you compare this with archiving the web, it turned out to be much more complicated. Because if you want to make a copy of the web, you only need to speak HTTP and look for URLs. Here we need to speak GitHub event feed language, GitLab event feed language, Bitbucket event feed language, Debian package language, the Ubuntu package language, RPM package language, etc., which is a mess. But so we had to build translator for all these kind of things. And when you talk to these places, you just ask, hey, what are the projects that you are maintaining today? You get this long list, the 350 million projects, right? But then, since we in computer science are not satisfied if we do not reinvent the wheel every 2 minutes, you will find out that these projects are maintained using tons of different version control systems, tons of different package managers. So you have Git, Subversion, Mercurial, Bazaar, CSV, etc., etc., etc. And so many package formats. And so we had to do the extra effort, go the extra mile to build another set of adapters that actually read the history of the version control system from all of these different things and put everything in a single giant deduplicated graph that contains the history of software development over time in a single data structure, which is very simple. You see, here you have file contents, directories, revisions, releases, snapshot, origins. Nothing more. So you should be able to read this data structure in 10 years, in 20 years. While reading a Subversion repository or a Git repository, a Mercurial repository, in 10 years we will see, depends on the version you are using, etc. The result is that now you have, and even these numbers are not up to date, but in this graph today is over 50 billion nodes, over 800 billion edges. It is probably the biggest social graph that you can find on the planet which is publicly available. There are bigger social graphs, the web, etc., but where do you find them? Typically these are in the data center of Google or Microsoft, etc. But this one you can get access to, and I can tell you how. And each of these nodes is identified by an identifier which is called the software hash identifier, basically a cryptographic hash with some prefix that say this is a software hash, this is a version number of the algorithm used to do computing the cryptography content, a tag that says whether this is tagging a content, a directory, revision, release, or snapshot. And then you can add here extra qualifier that tell you where in the graph you have found this particular object. So the same file can be in 1,000 projects. So this identifier here identifies a file content, but not necessarily where it is. And so I can add the information by saying, actually, this file it was called foo in that repository in that area, etc., etc. This is now an ISO standard. It is an ISO IEC standard 80670, which is important for industry and other places. And it took us 4 years to get there. I mean, standardization is complicated. It is done to make sure that everybody can compute this identifier independently, okay? And there are already 3 different implementations of this thing. So now I would like to show you a little bit of the things that you can do, okay? Because talking is nice, but showing is better. So let me do one thing. So let me go. Okay. The screen is, no, it's readable, I think, okay. So here we are on archive.softwareedge.org, okay? So it's the entrance to the archive. If you go down, you see these are the current numbers. So you see, actually, we are over 360 million project and 23 billion unique source files in this moment. Here you have a breakdown of the different origins. I mean, a copy of this picture was put in the slide. And for example, when I was saying not just GitLab.com, if you click here, you see the many instances of GitLab we are already archiving regularly. How do you use it? But imagine I'm looking for a project of mine. This search bar is a search engine only on the URLs, not of the content of the archive. We do not have the resources yet to build a full text index on the archive, so but at least we provide this to you. So if I do this, I end up finding several variants of a project of mine, which I wrote in 2012 with a friend to do map reduce on a multi-core, I mean, something like this. See, this is exactly, you are entering to the archive. You see, the information is where it's been archived from. You can see how many times it has been archived. This is a visits view. Okay, and each visit view, if you click on the visit view, you get the status of the repository on that moment in time, including all the version control systems. So it's a history of histories of development, actually, it is going on. And then you see the code, the different branches, the different releases. Here you have the hash of the tip revision, you have the comments, the authors. You can see all the history of development, of course. Let's see, did I click on the thing? Yes. Here it is. Here you have all the history of development, which is traced in let me remark already something. For this seems easy because my project was on GitHub. So you see Git commits like on GitHub. But if your project was on a Subversion system or a Mercurial system, etc., you get exactly the same view with exactly the same identifier. It's a unified view of the work. So for example, here if I do, check this particular commit, I can see the changes with respect to the pressure version. So this is designed like for a developer. You can see what changed on the last version, but it is an archive. Okay. Compare with a zip file on the digital library of the ACM. Not exactly the same, right? So this is a little bit more nifty. Now, again, it's not criticism. I mean, what other people did before the existence of Software was the best they could do, but now we have better things. Now, what you can do, you can go to visit a piece of code. For example, when I wrote an article with a colleague of mine in 2012, Marco Daneluto, who is an expert in HPC, we wanted to point to a particular fragment of code. We copy-pasted it into the article, and we were very proud because we managed to implement a map reduce routine in 29 lines of code. I mean, with a lot of tricks with the underlying operating system. And we put it in the paper. Then, a few years later, I discovered that Gitorios disappeared. And actually, my code wasn't Gitorios. So my paper was pointing to nothing. Okay. And then I said, okay, let's try to find the software, etc. Try to find the software. I had a copy of my machine, but I didn't find exactly the same version. Then at some moment I found out that what we had put in the paper was not exactly the code, because we had page limits, so we had to remove some lines, etc. And now I have a new version of the paper where we say, this is a simplified presentation of the algorithm that you can find there. And so, what do? You pull out this tab, you see that provides you the permalink with the identifier all the time. You copy the permalink, and then you put it in the paper, and when somebody clicks on the paper, this brings you exactly to the archive in front of the exact fragment of the code in the exact context where it was used. So you see the change. This is a complete change in the way you write paper, and the way you can do reproducibility, and the way you can expose a software which is interesting for you for others to read. The other thing that we added just a few weeks ago, if you look inside here, now there is a special file which is called codemeta.json. This is a linked data representation of metadata related to this particular project. So you have the license, you have the repository, the dates, etc., the author, description of the author, etc. If you add a codemeta.json file or a citation CFF file, which is another standard coming out, to one of your repository and you archive it in software heritage, you immediately get this orange tab on the project. When you pull it out, you get a full bibtext snippet that points to exactly what you are looking at. So if you are selecting a fragment, you get the code fragment entry that points to exactly the code fragment you have chosen. But you can also point to a snapshot. In this case, it is a software without the fragment. You can choose what you want to reference. Then you copy, paste, put in your paper. You use a software style available on Citan. Actually, this is included in the ACM article class today. And you have citations. Actually, you can do even better now because we are talking about open science and characters. You know, effort we made in France a lot for making software development recognized is to ask institutions in their evaluation report to provide a list of the software which is produced by the institution. And what happens? The traditional way of doing this is, and I need to shorten a bit. No, it's fine. Okay.
Just worry about the microphone, if it's working well or not.
Ah, okay. No, every now and then it goes away. And so what happens is that typically on a Friday evening, you get a desperate message by the director of the lab saying, we need to fill the report on the software. Please, by Monday morning, fill that form out back there and see what software, who wrote what, I do not know. So now what we do, and this is something that from a mountain works only in France, but let me show you how this works. Imagine this is a version of my software that I want to reference for a report. I copy the identifier. They are connected to the national open access portal. In France, we have one global open access portal, which is called HAL. I connect to this thing because I'm registered there. And now I say I want to declare my software. Upload. Need to traverse the ocean and come back. A second. That's surprising. This is slower than software heritage. I mean, come on, please. Well, anyway, so I can tell you what happens. I mean, it will propose me to put in the software hash identifier. If I put in the software hash identifier, it connects to the archive, look for the metadata file, get the metadata information there, fills the form for me. Then maybe I can review the form. I say submit. It goes to a moderation loop. So we have trained people in libraries and different, the people that usually work in libraries, to do quality moderation of the metadata, spot duplicates, check whether the information is correct or not, and then, well, this is really not working, but I mean, and then you get, it's strange that it is not working. And so, after back and forth with the moderators, this is published online. You have the record published online. So next time that my lab or my university wants to make a report, what do? They go to this page here, which is called HAL Tools. You click on Create Your Own Web Page. Then you go down here and you look for software. Software is here, logiciel. And for example, I want the software production of the Laboratory of Informatics and Robotics of Montpellier in south of France. I want this separated in different tabs, and I want the abstract of the software too. Then I click on Show, and I mean, the thing is a little bit, no, let me do this. Did I click on Show? Okay, here it is. And now you get this URL. This URL is permanent, so you can make the query. And now you have the list of all the software that were produced by the Laboratory of Robotics in Montpellier, one by one, okay, with the abstract, the affiliation, the authors. And for example, if I look at this, I do not know these kind of things. I'm just randomly going there. Here is the entry. So you see the name of the software, the different authors with their affiliations, the pointer to the version archived in Software Heritage. You can go there. So if you click here, you go to the version which is archived on Software Heritage, so you can pull the identifier, get the version, etc., etc. You have the abstract. You already have a simple citation if you want to do copy paste, etc., etc. And the keywords and all the other things. So you see, and people are using also this on their own web page to have the list of your software contribution together with the list of your publication. And since I'm an old guy, and one of the reasons I have a gray beard because I spend too much time filling forms here and there, my real focus from the very beginning is to make this as painless as possible for us as researchers. So you have seen, no, I didn't yet show you everything. Because to show you how easy it is, I also need to show you how can you make sure that your software is archived. Let's do the full pipeline in a second and see how it works. Come on, GitHub, wait. Or is it your network who is filtering something? I do not know. Come on, really? This is not me, this is the network. You have, okay, well, okay, so I need to tell you what would happen, okay?
But very important, we do not have any problem with Software Heritage. It's working all the time.
Software Heritage is working, yes, but GitHub not, I do not know. But so what happens if you go to any well-known software development platform, so GitHub, GitLab, Bitbucket, Git, etc., you can install a simple browser extension that you will find here. This browser extension is called Update Software Heritage. And once you install it, when you visit a platform, you have a nice tab, color tab there, which if it is green, it means archived, up to date. If it is yellow, it means archived, not up to date. If it is gray, danger, this means not archived. And as soon as you click on the button, if it is not archived yet or not up to date, you trigger archival immediately. Okay? And so it can be done automatically. You can also set up webhooks on your platform to trigger archival whenever you make a commit or whenever you make a modification or create a branch or something like this. Word of warning, we obey this kind of webhooks only once a day, okay? So if you send 100 commits, we do not do 100 times the archival the same date. It's once a day. Okay. And then all this is totally possible. Here you have a full description of how this works. You also have animations that, no, not here. You also have animations that show you how you can actually set up a webbook there. You see it is moving. I mean, so you can go there. I'm actually super easy. So let's sum up. I am a developer or a researcher, and I want to do the full pipeline. So easy thing. I create my project. I put it somewhere on a GitLab here, on a GitHub in another place, on another code hosting platform. Doesn't matter. Then I trigger archival immediately without waiting our crawler to come over again. And when how do you trigger archival? Either with this browser extension here, or by going directly to this particular place where you can declare any repository under one of the supported version control systems. Like for example, here I'm saying, go and archive this particular repository on GitHub. Then I go on the archive queue, and you see, this was, it's already done. In a few seconds, it was already done. This is failed, and this is failed because I just didn't copy. I mean, so you need to be careful by putting. If you make a mistake in typing, it doesn't work. That's why the browser extension is safer. And this has already been used 1,800,000 times since we opened the service for the people. So, saying again, I create my project. I put my code meta file inside. Make sure it is archived, one click. Copy the identifier, 2 click. Go to my open access portal national, okay. Click on upload, 3 clicks. Paste the identifier, 4 clicks. Okay. Click on submit, 5 clicks. End of story. Then if I didn't make mistake in the metadata, that will be published. And then whenever you get a message on Friday night, you just say, hey, my stuff is there. Go fetch whatever you want. I mean, it's not up to me. Okay. And actually, this is starting to be used at national level for the evaluation of the universities, okay, in this kind of way. So I hope this gives you a little bit of an idea of how useful this can be for open science in general. But since we are among friends in a computer science department, I would like also to show you something else, because you have seen this graph, right? Wow, that's a nice toy. I mean, you have a 50 billion nodes, 800 billion edges graph. What could you do with this kind of thing? Actually, can you get it? Yes, you can. We did, since the beginning, I was dreaming to make it easy for other people, other teams, to do studies on this incredible piece of knowledge. And so, if you look for software heritage, open dataset, AWS, here, we had an agreement with the people in Amazon. They run a program which is called the Open Dataset program, where they provide free storage and free bandwidth for datasets which are open. For example, the common crawl of the web is on this registry. Here you find the software heritage dataset, and if you see what is written down, if you want to access it, you just do this with no sign request. You do not even need an account, okay, to access the content and use it. And we publish regularly every 6 months, and now we are trying to do it every 3 months, a dump of the state of the graph for you to use in your research. And this is typically, for example, done in columnar storage, so you will find .orc files there if you know what it is, but otherwise there are adapters. You can also use it directly using Amazon Athena. I do not know if you are familiar with this kind of technology, but there is an open source tool which is developed to do SQL queries in a massively parallel way, which is called Presto. And Amazon has their own implementation, which is called Amazon Athena. And if you go there, now here I'm using my own account. If you go there, you can connect directly these data sets which are stored there with your query system. So this, for example, is a data set that comes from the export we made in last December. And the interesting thing I would like to do is showing the power of these kind of things today. I remember a few years ago, I have seen a paper done by people in software engineering that were trying to answer the question, what is the most popular commit verb used by developers? So let me remind you a little bit what this means. So when you do a commit, I mean you do a modification of code and then you git commit, git push, whatever, you are asked to put a message there to say what you did. And the good practice is that this should start with a verb because it should read like this commit will, and then the verb. So for example, this commit will add this functionality. This commit will remove useless file. This commit will fix bug number. So I'm not sure this is super useful, but I mean, they wanted to do this kind of thing. And the paper was saying, okay, so we hired 3 postdocs, we bought a machine, we did a lot of work, we downloaded 150,000 repositories from GitHub, and do this and that, etc. And after 18 months, here is a result that we have obtained. Let's try to do the same, okay? So now, as I told you, this graph is a standard representation of what is available in all forges. In particular, you don't see here, you have the content table, the revision table, etc. So what we do is we select from the revision table the field message, which is a commit message. We restrict only to messages which are smaller than 1 megabyte. You say 1 megabyte? Well, there are commit messages which are bigger than 32 megabytes in the archive. I do not know why, okay? But it happens. Then you take the message, you convert from OTF-WIT, we remove space before and after, then we split by space and we take the first part. Then we put it in lowercase and then we take the stem of the word to put things together. So we do this selection, and so we have this single thing, and then we count the occurrence of each of these things, we drop empty lines, we group, and we take the first 20. So now I'm taking bets. What is the most popular commit verb, for example? What do you believe? Fix. Fix? Okay. Bug. Merge? Make. Add. Okay. Well, let's see. So, but you say, hey, come on, this takes 18 months. No. Now, we can run it. We run this on the export that was done in December. You see, the economic model of Amazon Athena is they charge you only for the space, for the size of the data that you scan. And it costs $5 per terabyte, the scanned. So here I'm almost at 50 cents. Then going a little bit up, so I'm almost at half of the price of a coffee. Then we're going a little bit higher. It's done. So maybe less than the price of a coffee. 40 seconds. And Now you have 500 million is update, 250 million is merge, but you know, I mean, add is there, fix is there, the other thing, etc. So you say, okay, it's a kind of a toy, okay, but this shows you what you can do with this kind of thing. But there is more, because you know, this is a query doing SQL, but SQL is not well suited to query a graph. So if you really want to query a graph, you need a way to visit a graph efficiently. And so there is other work that I have shown in previous talk. I will send you the link to the previous talk because I'm completely over time right now. So please kill me when you want. Okay. Stefano Zacchiroli, my colleague, developed together with incredible people who work in web graph compression, in particular Sebastiano Vigna and Paolo Boldi. There is an Italian mafia around software in some sense, and but all outside of Italy. And then actually this allows you to have the full graph representation in central memory in less than 400 gigabytes. So this means you can do traversal at super fast speed. You do not need to call APIs or whatever. So if you combine these two things, you can do something I prepared for you last night. Let me see if I can find it easily. I need to go here. No, Evans there. This is a project, so I probably is here. It should be here. Yes, let me see. And let's see if you recognize yourselves in this kind of thing. This is a automatically generated report on software developed in this university as seen through Software Heritage. How does this work? I took the USP.br stem of the email addresses that you use it. Then we use the SQL query to get all the email addresses that end in USP.br. Then we visit all the graph with the graph technology, because it's a big graph, and we mark all the commits where there is at least one committer that has one of these emails. Then we traverse the graph and go up to the origins, and we count from these origins all the commits done by people with these emails. Okay. And then we take the first committer, the last committer, because I cannot, so I try to do something, and let's see. And then the result is that, and I only consider project where there are at least 20 commits. So just to remove a noise, which is probably not correct, but we can recompute if you want. And the result is that I see that the software development activity for this university that we see is from 1998 to 2024 with 1,600 contributors that made at least more than 20, they made at least the first or the last contribution to projects that have at least 20 contributions from the university. These projects are 3,277 projects, and the total number of contributions across all these projects are these ones. Okay. Then you can start playing games and say, okay, but what is the density of contribution per project? Like for example, there is one project here where you contributed more than 4,000 times. There is one which you contribute 2,200 times. Then you want to know which ones, okay, of course, etc., etc. Then there are tons of projects where there are just a few contributions, just to make a minor fix. Tons of tables, of course, that you can create like this. Let me go to the textual representation. These are the projects with most contribution. And here I'm entering into the danger zone because I'm not sure if this is true or not. But for example, the project with the biggest number of contribution coming from your university is this one. Is it true? I do not know. You know the project. Okay, so fine. Okay. But then you say the other ones, etc., etc. And don't worry, I will send you the PDF with this analysis. Okay. So you can do this kind of. You find yours? It is there. Okay. But so you see, I mean, this dream of building a very large telescope for exploring the galaxy of software development is starting to become true when you start doing this. And the other crazy thing is that, when this came out 2 weeks ago, because one of the universities that support us asked us, can you provide us with some numbers of our software production? I mean, actually it happens to be my university. It has been a big supporter for a long time. I said, what can I do? Because we do not keep track of the people visiting the website, but maybe there is something we can do. So we had the idea of doing this, and from the idea to the implementation, it took a week. Because the rest of the technology is already there. I mean, the compressed graph was 6 years of work. Okay. So, again, I hope I give you an idea of the kind of things that become possible by using this kind of technology today. So now, yes. These are this is a project that has the topmost number of contribution from your university. I dropped everything that has less than 20 contributions from people here. This is the initial filter. From here. No, not from everywhere. Because I wanted to focus more on projects where you are more relevant. But this is parametric. You can rerun the thing. And I'm trying to since it's very, very fresh, I'm trying to package the pipeline in a reasonable way, so you will be able to rerun the thing by yourself. And well, okay, enough with this. Let me go back to the presentation. So the demo time was a little bit longer than expected, but I hope that you enjoyed it because it is more directed than just looking at the slide. So I will skip. This is a slide where you have a lot of links. So if you click on a link, you will get one or the other of the demos that we have seen together. So we skip. These are animation that I can skip because you have already seen. Some in the adoption indicator, like for example here, in computer graphics, you have an initiative which is called replicabilitystamp.org. So all the community of computer graphics worldwide, they publish articles together the software do image manipulation. And they created an international committee that look at the paper, look at the software, test whether the software does exactly what it says. And if it is the case, you get this stamp that says, okay. But before, they only provide the DOI for the paper and the link to the repository. But the repository can go away. You do not know what version was identified. Now they add the link to the version archived in software systematically. There are journals that do the same. And actually in France, so this is now mandatory to archive software this way, especially if you get a national grant for your research. Now let me skip all this. And maybe this is important. You see, at the beginning, we started with the idea of building an archive to avoid losing things. Now we discover we did much more than that, because it's not just an archive, it is a graph, and not any graph, but a Merkle graph. So basically we have a blockchain of software development. when you think about blockchain, people think about cryptocurrency. So this is a blockchain plus a consensus algorithm. We don't have the consensus algorithm, we only have the blockchain, okay? Then this is an infrastructure for open science, you have seen, I mean, for reproducibility, etc. And since we are also removing all the details from, I mean, if a piece of software comes from GitHub or GitLab or for a Debian package, etc., it is stored the same way, it is presented the same way, identified the same way. So basically we have done all the data cleanup and data normalization, which is typically necessary before doing massive data analysis or machine learning. So this is an incredible playground. And this is just what happened last year. I promise, this is the last slide. I am a very dangerous person. In general, I have a tendency to speak too much, but you see there is some passion behind doing this. Otherwise, you do not spend 10 years of your life on some crazy idea like this one. But anyway. But so this is fascinating. This is what happened just last year. So one, we joined forces with a consortium to try to expand the work that we have been doing with the Ministry of Research and to expand into all the publication worldwide, not just the publication in France. That is to say, taking all tens of millions of publications worldwide and run the analysis to spot mention of software in there, and to connect this mention of software to the archive. So if there is a mention of the software we didn't archive, we want to archive it. If there is a mention of software that we archive, we want to update the archive, we provide the link back. And we want to get the metadata of the articles that mention the software, which is super interesting for building a search engine later on. Because if you look for a software which is relevant in molecular biology, if you know that 1,000 articles in molecular biology have been using that software, it helps a lot, right? And instead of just reading the README. Then last February, February last year, the first open large language model for coding was published by the people at Hugging Face and ServiceNow with the help of NVIDIA. They provided the cluster. And this was built on a subset of the Software Heritage Archive for training the data. But everything is open, so you know which file was used. The pipeline is open source. You can train it. And there is an opt-out mechanism for people who do not want to be used for training. Then there is a project started on security, because you have seen the graph, right? I mean, I have used the graph to find the project you work on. But imagine that you find a particular file has a vulnerability. A natural question is, hey, is there any project outside which is still using a copy of the vulnerable file? What do? You take the file, you navigate in the graph, look at all the origin, you pick the latest snapshot, check whether this file is still there, and you immediately know all the software which are vulnerable. Now, we are not publishing this information for the moment, but it can be done. There are connections with other academic structure. I imagine many people here are still using Zenodo for archiving software or something like this. So now that you see Software Edge, please use Software Edge. But if you really want to use Zenodo, you can. And now we have doing integration. So as soon as you archive something on Zenodo, which is in the category software, it is archived in Software Heritage too. Last but not least, we started a project on expanding Software Heritage. This is called Code Commons, to add much more information, the link with the article, link with the quality of the software, etc. And so if I can conclude, let me finish here, because again, it was very long. So we started this crazy thing 10 years ago. And actually, I was so optimistic. I had an idea that in 3 years we had everything running. Not at all. But anyway, the point is that we discovered actually this is providing a lot of value to people. And so it's really interesting to know that Software Edge today is really vendor neutral. We are not a company. We are not selling anything. This is a foundation, non-profit, hosted by INRIA, which is a public research organization in France. Okay. Everything is open source. It is designed to be worldwide and long term. It is in partnership with UNESCO, a partnership we have renewed in 2021, and we have the meeting at UNESCO every year. Okay, so I hope to see some of you next year. We'll see in Paris, a nice place. And we already provide everything needed for doing archival, reference, traceability, citation, qualification, and the kind of report you have seen right now. What is left to do? I mean, there are so many things left to do, but particularly in academia, which was the subject of the presentation of today, I think it is interesting for people to know what it is. Show this to people around you. I mean, as soon as people see what you can do, they usually adopt it because it's very easy and very practical and very satisfying. But if you have an open science policy in the university, in France we are pushing to every university to have an open science policy. At least they declare what they want to do. If you have an open science policy, consider including software engineering in that. You are taking no risk and you are actually going in the right direction. You can integrate it with your academic infrastructure. You have an academic infrastructure already. So for example, a GitLab or something like this, you can ask us to automatically archive it. We can do it immediately. Or if you want to create reports like the one that you have seen here, we are working on mechanisms to make it possible for you to do it. And of course, I mean, we are totally non-profit. So the model, the economic model, is to spread the cost among the users. So instead of spending money rebuilding another software archive for only archiving the software USP or the software MIT or the software Stanford or the software etc., let's pool the money together and build an archive which is a universal archive. Also because if you remember the graph, the picture with the dependencies, when I talk to people working in libraries and archive, they tend to tell me, yeah, but I just want to archive the software produced by my researchers. Sure, but then if you want to run it again, it depends on tons of software that your researcher didn't write. So if you don't archive that, how can you do it? And say, and so, or they say, but we need to tell to the people who write the software on which we depend to put it on a place with the DOI. Not sure that the Linux kernel will accept the suggestion, for example. You know? So now you have the possibility to archive everything as soon as you need it. And you can get involved. So then everything is open source. And actually, if some of you are interested in collaborating with us in the new project, which is called Code Commons, we even have position open. It can be either software engineer or data scientist or this kind of thing. Just connect and let me know. And again, my apologies have been very, very, very long, but if you have any question, I'm more than happy to answer to you today. Thanks a lot for your attention. Okay.
We have time for some questions.
Thank you for the great talk. So you mentioned that you have a long-term initiative, right? So what is the plan to make sure that in 50-year times, the link I put in my paper to software heritage, that it's not going to be broken?
Oh, sorry. Now it's super loud. The very good question here. So when we started, actually the first year was spent in trying to understanding the long-term approach we could have. And so we had to identify a bunch of challenges. So the first challenges was there are many. I don't know if first, but one challenge is technical. Okay, so for example, what happens if the data center goes up on fire and we lose everything? Okay. A second is security. What happens if we get hacked and somebody remove everything? Or maybe I wake up in the morning and got crazy, I have the password, they remove everything in the archive. Okay. Then the financial. What happens if somebody stops funding this effort? Then legal. What happens if some legislation is passed that makes it difficult or illegal to build such an archive, etc. So thinking about this, you have basically two approaches. One is to say, I'm the strongest in the world, don't worry, we will do the best possible. The other is to say, let's try to design something that will try to survive in different ways. So the approach number one was, we started in 2018 a program for a network of mirrors worldwide. So number one, we have 3 copies of the archive under our own control. So 1 copy on our own Iron, 2 copies, 1 on Azure and 1 on AWS clouds. So 3 completely different technologies, 3 completely different places, etc. But unfortunately, these are copies under our control. We can destroy them or we can get out. The mirror program is different. These are copies maintained by other institutions with which we have agreements. They can only read from us to get new data, but we cannot write into their archive. It is append only. So even if somebody hacks what we do or remove what we do, the copy which is in another place will stay. So that was the idea. And now how many mirrors we have? So we have 1 running mirror, one at Enea, which is a large research organization, alternative energies in Italy. A second one, which is being fielded right now in Greece by GRNet, which is a national high performance computing and network institution for academia in Greece. A third one is being built in Germany by another academic, and the 4th one is planned in Spain. So this is a way of reducing the risk of losing the data. And since you are using intrinsic identifiers, identified here, even if we disappear, we go with exactly the same identifier to one of the mirror, and you will find exactly the same thing. And you can download the content, and you can recompute the hashes, and you can check that it is exactly what you wanted, because your identifier is the hash. And so you can check things. Financially, we try to spread the spectrum of potential funders. You see, actually I wrote a book against Microsoft 25 years ago, so I was in the blacklist of Microsoft 25 years ago. But now Microsoft is also a sponsor, and my opinion is that they changed it, not me, but they're also a sponsor. So we have Microsoft as a sponsor, we have IBM as a sponsor, but we have the Ministry of Research in France as a sponsor. You have 4 or 5 different large universities as sponsors. You have different organizations as sponsors. We have the Sloan Foundation providing funds for developing things. So we try to spread around. Okay, now we need to grow the constituency much more. So I hope we will have people in Brazil jumping on board, people in other countries jumping on board, because the infrastructure we are proposing, again, from day one, it was not an infrastructure designed to be French, nor an infrastructure designed to be European. It is an infrastructure designed to be worldwide. And you can trust me because I'm Italian, I'm married to an Argentinian, I live in France, and I collaborate with people worldwide. So it's really in my DNA to do these kind of things. Yeah. And if you look at the other people in the team, we are like this. Okay, my advisor for helping in building the organization is Jean-François Dramatique. He was a guy who directed the World Wide Web Consortium with Tim Berners-Lee many years ago. So these are the kind of people we are looking for. To help us, you have shared value, and work together in building this thing. So I do not know if this answers a little bit your question, but.
Let's try again. Another quick question for a long answer.
Sorry.
Hi. Thanks for the amazing talk. I would like to know if you have plans for improving reproducibility of scientific software, because there's a big problem where software that was made many years ago solved, and it was referenced in science publications, and we cannot run nowadays. How can we guarantee that our software will run later?
Thank you. Very, very important question. Thanks a lot for pushing me to say things I didn't plan to say today. So, I mean, we are very much involved in everything related to reproducibility. So you see, what we provide right now is the ability for you and the people that read your paper, or for you reading the paper of ours, to have exactly the version of source code they used. But the source code alone is not enough. So we are also working with other people. You know, in Debian there is a project which is called reproducible builds. And some 20 years ago, a couple of ideas came out on functional package managers. I do not know if you know Geeks or Nix. Does it ring a bell? So the idea here is to build software that will be bit by bit identical to the one you built 20 years ago. By doing what? By getting the source code, the original source code, not just of your software, but all the dependency down, and rebuild completely everything. And this system called Geeks or Nix are called functional package manager, because the idea is that when you run them 2 times, you get the same thing, like a function. F of 2 is always the same result. And the only problem they have is that they rebuild everything from source. And where do they get the source? On the internet. And what happens with the source on the internet? It disappears. So what we did with them is to create a connector between Geeks and Nix and Software Heritage, which is actually transparent. So if you are a user of Geeks or Nix today, you do not even notice. So you do the run. If the software is no longer available upstream, it automatically falls back to the Software Heritage archive and fetches the package there. To make sure things work well, we have a sort of connector with Nix and Geeks packages that every time there is a new source included in a package, pushes the source to our archive this way. And actually, there is a paper by Stefano. I think that is, I don't know if it is already published or he will publish this. No, I think it will be published in MSR 2025, the mining software repository. But I don't remember. I can find the paper for you. They did an experiment to try and use Nix or Geeks and unplugging everything except the fallback on Software Heritage and see what happens. And they get at something like 90%, 95% of rebuilding the things from scratch, which is impressive. Now, using Geeks or Nix is not easy. It is like the time that I had my student come in and tell me, you are still using Subversion, you should use Git. I mean, why? I mean, that's another thing. What is push, what is pull, I do not know. And now everybody uses it. So the learning curve is a little bit steep. But if you really want to go into that direction, that's the best of breed I know of today. Then if you also ask me to keep a copy of the machine, this is outside my competence area for the moment. I mean, for the hardware, this is not me. But for the software, we are trying to do as much as possible.
Okay, so maybe my last question, easy one. What do you want to see as software heritage in 5 years? What do you like to see happening?
Many things. I mean, 61, so I do plan to move on still 10 years, okay, but not more. So the need to also go fishing for some time. But then the idea is, in 5 years, I would really like to see the independent, autonomous international organization set up and running. For the moment, Software Heritage is hosted in India. We have a separate entity which is called the Software Heritage Foundation, but it's actually not a legal entity. We are hosted by a hosting organization. And we are assembling an advisory board right now of international people to try to help us planning the transformation into an international organization. International means really international, okay, with people from all the countries, with a stable funding model. And I would like to see, really, in 5 years, I would like to see hundreds or thousands of papers published using the archive to do interesting things on software, building better software, analyzing what is going on. I mean, the sky's the limit. In the moment that you can actually use this infrastructure, you can focus on the interesting things instead of going up and downloading GitHub every 2 minutes to do some kind of experiment. And not just in computer science. You know, there are people doing history. of computing. And they are interested in studying the evolution of the communities contributing to software. So for example, you look back at Prolog, created by Kolmerauer in 1972. And you want to know how Prolog spread in the world, who contributed, etc. Now that you have a tool like this one, or econometrics impact of software, this kind of thing. So not just in computing, in a lot of discipline, but it must be easy for people to ask the question and get the result. And so there is a lot of things yet to develop around this. And I hope you will contribute.
Thank you again. Thank you very much.
Thank you for your time.